Hey guys, and welcome back to another video. So today, this has actually been requested a couple of times, but I also thought it'd be a good paper to do. So Pearson has released a 2023 practice paper aiming for a grade 9. So it's going to be some pretty tricky questions, I imagine. So just to be clear, I'm going to go through every single question in this paper. I will say that I have done one or two of these questions before and I've already uploaded them to YouTube, but we're still going to go through them again anyway. And even if you're doing like AQA or Educast or anything else, this will still be useful because, again, keep in mind the specs are all the same. It's just kind of the structure of the questions, okay? So let's jump straight in. I also have the link to the paper in the description in case you want to follow along. So what you can do is open up the paper, do the paper yourself, and use this as like a mark scheme if you like. So Lena spins a biased five-sided spinner 40 times. Here are her results. Cool. She's going to spin the spinner another 2 times. Work out an estimate for the probability she's going to get a score of 5 both times. So what we want to do here is look at the numbers associated with the number 5, because that's what we're interested in. And that's 10. So I'm just going to write 10 for now. And also this is a non-calculator paper. It's a paper 1, just so you're aware. And then we're going to do that over all of these numbers added together. So 10 plus 7 is 17, plus 9 is 26, plus another 8 is 34, plus another 6 is 40. So 10 over 40. And then we need to, she's spinning it twice, right? So we're going to multiply because she's getting a 5 and a 5. So when I say the word and in probability, it just means multiply. And what's the probability of getting a 5 the second time? Well, it doesn't actually get affected, so it's still 10 over 40. And if you notice, you can cancel out the 0. So if your fraction, the numerator and denominator, ends in a 0 or multiple zeros, you can actually just cancel them out. So that's a quarter times a quarter, which is, of course, just 1 over 16. You just times the top, times the bottom, all done. Okay. Derek is going to spin the spinner a large number of times. Work out an estimate for the percentage of times he can expect to get a score of 1. So the reason why they put this sentence, he's going to spin it a large number of times, is the idea that this is our experimental data, right? So because it's our experimental data, if you do it a large number of times, the percentages should stay the same, right? Because probability always stays the same. So what I'm going to do is I'm going to take the probability of getting a 1, so that's 6 out of the total 40. And if I reduce that quickly, we can half that, so it's 3 over 20. And then we're trying to turn that into a percentage, right? So you can either times by 100, right? That's one way to do it. So if you're able to do that in your head, then well done, you can times by 100. Or you can just make the denominator equal to 100, right? So if I times the bottom number by 5, therefore I need to times the top number by 5, I get 15 over 100, which is 15%. Okay, so if you make the denominator equal to 100, then you can just use the top number as your percentage, which is pretty handy. So that's question 1 done, not too bad so far. Table shows the amount of snow in centimetres that fall each day for 30 days. Work out an estimate for the mean amount of snow. Okay, so this is, again, a fairly standard question. It pops up in paper 3 a lot, but this is grouped frequency data, and we need to work out a mean. So normally what you do with the mean is you add all of the data up and divide it by the number of data values you have. But for this case, because I have grouped data, there's 8 values between 0 and 10, 10 values between 10 and 20. So to work out the actual mean, you find the midpoint of all of these classes. So that's going to be 5, that's going to be 15, and so on. By the way, if it isn't obvious, what you can do is add the 2 values together and then divide it by 2. So 20 plus 30 is 50. Divide by 2 is 25 to also get the midpoint. That's going to be 35 and that's going to be 45. And now what we need to do is multiply all of the midpoints by all of the frequencies. So I'm going to kind of write that as a new column in my table. So we do 5 times 8, so that's going to be 40. 15 times 10 is 150. 25 times 7, that's a really good question. I think it's going to be 175. Yes, because 25 times 8 would be 200. 35 times 2 is 70. 45 times 3 would be 135. Okay, I think I got all those right. Add them all up. So if I add these all together, we get... So again, the next step would now be to add them all together and divide them by the total frequency, okay? So if I add these all up, I get 0 plus 0 plus 5 plus, that's 0, carry the 1. 3 plus 7 is 10, 17, 23, 27, 28, so 8 and 2, and then there was 1, 2, so it should be 570. Yes. Good. 570. Cool. I got a bit caught out. I should have laid this out a lot neater if I was going to actually add column method. So we have 570, and what's the total? Well, I could add all these frequencies up, but it tells me it's for 30 days anyway, so I know it's going to be 30 days. So cross out the zeros. 57 divided by 3 is going to be 19. So that is my answer. And it's an estimate, so it's 3 marks, not too shabby. And again, this table would constitute working out, okay? So doing this would give you 1 mark. Dividing this is the 2nd mark. Getting the right answer is the 3rd mark. Okay. Oh, that's ugly. Okay, fair enough. What I would recommend doing here is we have this kind of messy stuff. I personally like to get rid of brackets first normally. However, I'm going to make an exception because these are mixed numbers. Generally speaking, you can't calculate with mixed numbers. You can do addition, technically. The rest of them you can't really do. So what I'm going to do is change them all into improper fractions. So I'm going to keep that bracket there because I'm not doing anything with the bracket. I'm just changing into improper fractions. So to do that, you take the whole number and you times it by the denominator. So 5 times 9 is 45. Add the numerator, so that's 49, and you put it over the denominator. And again, I'm not really touching that at all. Do the same thing with this one. 4 times 3 is 12, plus the 2 is 14 over 3. Perfection. And that's going to be over 2 to the minus 3. And for now, I'm not going to touch that because that looks a bit ugly. Now, let's keep going. When you have this minus, whenever you have a minus outside the bracket, that just means you're going to flip the fraction, okay? So, again, I'm going to do this in very small steps, so you could do this a bit quicker than I'm doing it, but again, in an exam, I'd recommend doing it nice and slow because you tend to make mistakes. And all I'm doing is getting rid of that negative now. That's it. Times 14 over 3, okay? Now, this, when you have something to the power of a half, it means you're square rooting it. Okay? To square root a fraction, you literally just square root the top and the bottom. So that gives me 3 over 7 times 14 over 3 over 2 to the minus 3. It's looking pretty ugly still. So let's do this. You can use cross cancellation to make this a bit easier on yourself. So the 3 cancel with the 3, so they both become 1s. The 7 also becomes a 1, and that becomes a 2. So we're left with 1 over 1 times 2 over 1. So in other words, we're left with 2 over 2 to the minus 3. And what happens when you divide two numbers with the indices? Well, this indice is technically a 1. You subtract them. So it's 1 minus minus 3. So that's going to be 2 to the power of 4. And if you need to work out the exact value of that, that's going to be 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 again is 8, times 2 again is 16. 4 marks, not too bad. In terms of where you get the marks, you would get the marks for working out the fractions here. So just doing these kind of flipping and changing this would give you individual marks, okay? And it looks like I actually didn't put the over 2 to the minus 3 here. That's a bit of an oversight. Doing the cancellation, getting this, and then also working out the final answer. So pretty good for the marks. Not too bad. Okay. You may recognize a couple of these questions because I have done them on like shorts and made individual videos for them. But here it says the diagram shows a sketch of part of the curve with the equation y equals cos x. And p is the minimum point on the curve. What's the coordinates? Okay. So with the cos graph, it always goes between 1 and minus 1. Okay? Assuming there's nothing else here. They haven't transformed the graph at all, okay? This is just the cos x graph. So I already know that the y coordinate of p is minus 1. So I can get a mark just for doing that. So 1 mark. Cool. Now if you remember the shape, the way I like to remember the cos graph and the sine graph is that it changes every 90 degrees. So every 90 degrees it either goes from 1 to 0, 0 to minus 1, -1 to 0, or 0 to 1. So if I wanted to label these points, it's literally every 90 degrees something happens, you know? 180. So yes, I've already got the answer. It's going to be 180. But just to show you how I remember it, it's just literally just keep adding 180. Adding 90 degrees. And you can just keep 5, excuse me. No, that's 450. Jeez. Yeah. And 540. And so on, okay? So it's all, you know, you can just keep adding 90 degrees, and that's when something important happens, right? So yeah, nice and easy, not too bad. The diagram shows a sector of a circle of radius 18 centimeters. The length of the arc, so that means this thing here is 4 pi. We need to work out the value of x. Okay, so here, what I'd recommend doing is thinking about what is an arc. An arc is just a fraction of the circumference of a circle, right? Yeah, I can speak a lot faster than I write, of a circle. Okay, so what they've done is, it's like a pizza slice, right? So this is like a slice of pizza. It's just a fraction of a whole pizza, right? Now, the question is, how do we get that fraction? Well, what we do is we take the angle, okay, and divide it by 360. So if you were to take half a pizza as your pizza slice, you would be taking 180 degrees. If you're taking a quarter of it, you take 90 degrees, right? That's how we work it out. And we times it by the equation for the circumference of a circle, which is 2 pi r. Okay? So that, just stating that, gives you a mark. Okay? Just stating this fact. Okay? Well, as soon as we sub in the values. So we have x over 360 times 2 pi radius of 18 equals 4 pi. That gives me a mark. I'm basically just writing the question down again, which is really, really useful. In terms of, again, I'm trying to teach you the exam technique here. So, you know, some students will get like 0 marks because they don't even attempt it. If this question scares you, at least write something down. You can get a mark. 1 is better than 0, right? Now, here, I can do some pretty interesting algebra. Well, useful algebra. First of all, since there's pi in everything, I can cancel out pi from both sides. Okay? I can also divide both sides by 2. So that simplifies my equation a little bit. Now all I'm left with is 18x, because we have x over 360 times 18, over 360 equals 2. Now I'm just solving a linear equation. I'm going to times both sides by 360 to get rid of the denominator, well, to get rid of the fraction, which give me 18x equals 2 times 360 is 720. Now all I need to do is do x is equal to 720 over 18. There's so many ways to work this out. One way is to just keep cancelling down, so keep halving over and over again. The other way is, if I ignore the 0 for a second, how many 18s go into 72? Well, 18 at 18 is 36, which is half of 72, which means there must be 4 18s in 72. So how many is in 720? Well, I add the 0 back. So x must equal, I already forgot what the value was, 40 degrees. Okay? So you need a mark here. A mark for starting to kind of rearrange. So if you get a value for x like this, and then a mark for the final answer. Pretty okay so far. I actually can't remember how many questions are in this paper because I didn't look through it. Yeah, let's just hope that it's fine. So we have Alfie has 11 cards. He has 3 blue, 7 green, and 1 white. He takes 2 at random. What's the probability that he takes cards of different colours? So what I would recommend here is actually working out. So to do the different colours one, there's a lot of different combinations, right? He could get blue, green. He could get green, blue. He could get white, green. He could get green, white. He could get, I'm pretty sure I've missed one. Which one have I missed? Blue, white. You know? Now the thing is, working out all of these probabilities and adding them is a bit boring. So what you can do is you can use the fact, and this is one of the spec points, that all probabilities sum to 1. So there are 2 possibilities, right? Either they have different colours or they have the same colours. Yeah? Now, how many options are there for the same colour? Well, you can either get 2 blues, or you can get 2 greens, right? And he can't actually get 2 whites, right? So we can work out blue, blue, and green, green, and then just leave it as that, and that'll be fine. Which is probably the best way to do this question, okay? So I would then just do 1 minus that, and you'd get your answer. So the probability of getting 1 blue card is going to be 3 out of 11, right? And then we're going to times that by what's the probability of getting a second blue card? Well, it's going to be 2, because we've taken 1 blue card already, so there's only 2 blue cards left out of the 10 remaining cards. Then we're going to add that to 7 green cards out of 11 times, well, now there's only 6 green cards left out of 10. Now let's do this maths. 3 times 2 is 6, 11 times 10 is 110, plus 7 times 6 is 42 over 110. Add those together, you get 48 out of 110. Okay? Cool. Now this is the probability that we get the same colour. So the probability of getting a different colour will just be 1 minus 48 over 110, which gives me 62 out of 110. Bad. Which I personally think is an easier way to look at it. I will keep in mind, I want you to keep in mind that when it comes to probability, there is a bunch of different methods to do it. So you could have done the first method, right? So, you know, a blue, technically speaking, by the way, you didn't need a white and another colour, right? Actually, no, you did. Technically speaking, you could have done the first thing where you work out 6 different probabilities, or 3 or 4, however many you ended up doing, and you get the same answer. So keep that in mind, okay? I will have an annotation if I end up getting one of the questions wrong, by the way, just to correct myself. Or when I'm editing, I'll just like shove in a clip of me just being like, yeah, I got it wrong, I'm stupid. But if that hasn't popped up yet, then this is the right answer as well. Okay. Oh boy, it looks like it might be circle theorems. So A and B are points on a circle centre O. DBC is a tangent. AOB is X. Show that angle ABC, so that's this angle here, is a half of X. You must give a reason. So this is the one where you have to actually quote reasons, okay? Okay. Now, the thing I immediately look at is if I'm trying to work out this angle here, there's a few things I can see. The first one is that this must be a right angle because OB is a radius. And if you remember your circle theorems, radii always meet tangents at 90 degrees. So what we can do is say that OBC equals 90. And then you literally write the reasons that tangents are perpendicular. Yeah, I'm sorry, I can't write that faster on the graphics tablet. Tangents are perpendicular to radii. Okay. Which would be a mark because we're going to use it in our working out. Now, if I look at this triangle here, those two lengths are equal, right? Because they're both the radius of the circle because they go from the centre to a point on the circumference. So both of these are radii, which means this is an isosceles triangle. Which means this inner angle here, right, is just 180 degrees minus x divided by 2. Now think about it. The reason why I'm going to do this, imagine this was, let's say, 60 degrees. How do you work out the other two angles? I shouldn't have picked 60 actually because I realised it's going to be an equilateral one then. 80 degrees. You do 180 minus 80, which gives you 100, which is both of these angles, and then you'd half it, right? So each one would be 40. I'm doing the same thing, but I have algebra instead. Okay, fantastic. Great, thanks Windows Security. Anyways, so I've just done algebra instead. Okay. Now, I need to actually write working out for this. Base angles of an isosceles triangle are equal. An isosceles triangle are equal. Perfect. So that would be my reasoning for that one. And so to work out the angle ABC, well, the whole angle should be 90 degrees, and we already have this 180 minus x over 2. So what we're going to do is say that this angle is, so angle ABC is equal to 90 minus 180 minus x over 2. So what I'm going to do now to actually work this out is I'm going to divide these things both by 2. So I'm actually going to do the fraction, right? So that's minus 90. That'll be plus now x over 2. These 90s cancel, so we're left with just x over 2, which is the final answer. Cool. You could probably also use alternate segment theorem. So what you'd have to do there is actually draw out extra lines. It's a bit messy. I prefer this one. You might notice it's a new day. That's because I just got back in time from touching grass. I know, very special. But let's continue with question 8, where we left off. So here we have a solve 1 over x minus 1 over x plus 1 equals 4. And we need to give it in this third form. So what we're going to do, and by the way, since I can see this plus or minus, that means we're going to be using either completing the square or quadratic formula, just FYI. So what we want to do is whenever we have two fractions, as you guys know, my first step is to get rid of the fractions, but I can't get rid of both of them at the same time, not in any easy way. So I could times by both denominators, but I find that can be a bit tricky for some people. So what we're going to do is make the denominators the same, and then subtract them, then we're going to get rid of the fraction. So to make the denominators the same, we just times them by each other's denominator. So the first fraction, you're going to times by x plus 1. So that gives me x plus 1 over x plus 1. Don't forget, times top and bottom. Subtract, times the other fraction by 1. So that gives me, by x, sorry. Which gives me x plus 1 equals 4. Now I can combine it. We get x plus 1 minus x. That just gives me 1 over x plus 1 equals 4. We're going to times by the denominator of x plus 1, both sides. I'm just going to write it out fully, which gives me 1 is equal to 4x plus 1. Expand those brackets. 1 equals 4x squared plus 4x. Move the 1 to the other side. So yeah, we can use the quadratic formula for this, so let's do that. So if you remember the quadratic formula, it's x is equal to minus b plus minus the square root of b squared minus 4ac, and the best way to kind of learn this formula, because I do get asked that question a couple of times a day, is to, every time you use it, just write it out, and you'll just memorize it pretty quickly, and it's very efficient. If you don't have to remember, if they give it to you on a formula sheet, it's still worth remembering, because then you don't have to reference the formula sheet. So that's minus 4 plus minus square root of 4 squared minus 4. A is 4, C is minus 1 over 2 times 4, which is 8. So that's minus 4 plus minus square root. So we have 4 squared, which is 16. Then we have minus 4 times 4, which is minus 16 times minus 1 is plus 16. So that's 16 plus 16. So that's square root. Actually, I'll do it in 2 separate steps just to make it super clear. 8, that gives me minus 4 plus minus square root of 32 over 8. So now we can write that as a fraction just for now. So minus 4 divided by 8 is going to be minus a half plus minus an eighth square root 32. But if you notice in the answer, the square root has to be 2. So square root 32 can just be written as, because we know we're going to be dividing it by 2, so 32 divided by 2 is 16, so square root 16 square root 2. So in other words, it's going to be 4 square root 2. And we're timesing that by an eighth. So if I do an eighth times 4 root 2, that gives me 4 over 8 root 2, which of course is just a half root 2. So that gives me minus a half plus minus a half root 2. 5 marker, not too long, but it is a bit tedious. And yeah, that is the final answer for that one, okay? So always reference what the answer should look like in order to kind of get the right method for that. Point 9. So the centre of a circle is a point with coordinates minus 1 and 3. Point A lies on the circle. Find an equation of the tangent to the circle at A. So what I like to do is actually draw this out. So again, please do bear with me. My drawing is not great. Minus 1, 3, so it's somewhere over here, let's say. And let's say it's a circle that looks like that. Point A lies on the circle and it's 6A, so let's say it's over here, 6, 8, sorry. And we have a tangent here that we're trying to find the equation of. Now, the diagram doesn't have to be too accurate, to be honest, because this point actually should technically be higher, so this whole circle should be shifted to right and up. That doesn't matter. I'm just using it to visualize what's happening. So generally speaking, when you want to work out the equation of a tangent, what you do is, that's actually pretty terrible as a drawing. What you do is you take the gradient of the radius, negative inverse it, right? So in this case, what's the gradient? Well, it's going to be the change in y over the change in x. So the gradient of the radius is the difference in the y values, so 8 minus 3, over the difference in the x values, so 6 minus 1. So that gives me 5 over 7. Okay? Now the gradient of the tangent, because of circle theorems, is going to be the negative reciprocal of this. So all you do is you flip the fraction, 7 over 5, and then you change the sign. So in this case it's positive, we're going to make it negative. Okay? And the circle theorem I'm referring to is that the tangent always meets the radius at 90 degrees. So they're perpendicular, which means negative reciprocal. So now I have my equation is y is equal to mx plus c. And I've already worked out what m is. So y is equal to minus 7/5 x plus c. So how do I work out what plus c is? Well, I look at the coordinate 6, 8, right? So this coordinate here. And what that tells me is that when x is equal to 6, y is equal to 8. So we're going to sub that in now. So we've got 8 equal to minus 7/5 of 6 c. Let's expand those brackets. 7 times 6 is 42 over 5 plus c. Move that to the other side, so 8 plus 42 over 5 equals c. So 8 in terms of 5, so that would be 5. So if you want to make the denominators the same, you times this one by 5, top and bottom. So that's 40 over 5 plus 42 over 5, which gives me 82 over 5. Pretty big number. Now, don't make the mistake of saying, okay, that means y is equal to minus 7/5 x plus 82 over 5, because if we look at the form it's given to me, everything needs to be on one side, right? And they all have to be integers. This is why reading the question is really important. So if I move everything to the other side, we get y, and then I've moved this to the other side, so it changes signs, so that's plus 7/5 x. Actually, should we write in the same order too? So x comes first, so I'm going to... Right? The actual order in which you write it doesn't matter except in as the answer, but the actual, you don't have to like do anything special to it, you can just literally write it backwards or whatever. And it says that every number should be an integer. So to do that, if I times these all by 5, can you see it would give me integer values? So if I times the whole equation by 5, I get 7x plus 5y minus 82 equals 0, which is the correct final answer. Cool. Okay, so these proportionality questions, people do tend to find them quite tricky. So y is directly proportional to the square root of t, and t is inversely proportional to the cube of x. If we look here, it's a 4-mark question. So what we're going to do here is write out the information. So if y is directly proportional to the square root of t, that means y is equal to k root t. And if we use the second piece of information, we have t is equal to k over, because it's inversely proportional, so it's going to be k over the cube of x, so x cubed. Okay. Now it says find a formula for y in terms of x. So what we want to do here is work out the values of k in this case. So if I split my page in two, it says when y equals 15, t is equal to 9. So we can write 15 is equal to k times the square root of 9. So that's 15 is equal to 3k. So then k is equal to 5. Sorry, just 5, yeah. 15 over 3, which is 5. Do the same thing on the other side. So t is equal to 8 k over 2 cubed. So we can, well, I mean, 8 is just going to be equal to k over 8, which means k is equal to 64. Okay? Okay. Now, if we look at this equation here, right? If I look at this formula that we have here, so we have y is equal to k square root t, right? And here we have t is equal to 64 over x cubed. What I can do now is substitute this value, this equation for t, into this formula. In fact, instead of k, I should have written 5. Just change that quickly. So that means my formula for y in terms of x is y is equal to 5 times the square root of 64 over x cubed. So when you have these kind of two formula questions where they give you two different proportionalities and you need to find one equation, all you want to do is find the equation for the first set, find the equation for the second set, and then you can just substitute it in. Simple as. Okay? Okay, here's a triangle ABC. Find the value of sine ABC. So ABC, that is this angle over here. Okay? Give your answer in the form m over n, where m and n are integers. Okay, so this is a non-right angle triangle. So that means what we're going to be doing is the sine or cosine rule. Now, because it says sine here, I'm going to use the sine rule. So sine ABC divided by its opposite side, which is 6.5, should equal sine 30, because that's the only other angle I have, over 10.7, because it's the only other sine we have. Now, for sine ABC, what this means is sine ABC is equal to, move that over there, so that would be sine 30 over 10.7. So again, all I've done is times both sides by 6.5 times 6.5, right? And we have to write this now in terms of m over n, where they're both integers. So sine 30, hopefully you know this, is a half. So in other words, it's going to be 0.5 over 10.7 times 6.5. Now what I'm going to do is, to make these integers, I'm going to times the top and bottom by 10. So that gives me 5 over 107 times 6.5. Okay? Which again technically should be, if I put that over 1, what I'm going to do now is times this top and bottom by 10 to get rid of the decimal. So that gives me 5 over 107 times 65 over 10 times top times bottom. 5 times 65, you can use the column method, or you can times it by 10, which is 650, and divide it by 2, which is 325. Or again, if you want to do the column method, because again, this is a non-calculator paper, that's 25, 30, so it gives me 32, because add 2 as well. Okay, over 1070. Now, it doesn't say to give it in its simplest form, but that's probably a good way. It's probably a good step to take. So again, I'm going to divide top and bottom by 5. So to do that, I divide by 10 and double. So that gives me 32.5. Double it gives me 65. Divide by 10 is 107. Double it would give me 214. And that's the simplest form. But bear in mind, it doesn't actually say to give it in its simplest form, so you don't have to, okay? Because it will say like or equivalent in the mark scheme. Shows weights in grams of some potatoes. We need to draw a histogram. So histograms, you have frequency densities and you have class widths. So what you need to do here is work out the class width and frequency density of all of them. So I'm going to do this separately. So what I do is I add another little table, another column to the table, and I write frequency density, so FD. And if you remember, frequency density, FD, is just equal to the frequency, which is the number of potatoes in this case, over the class width. And I'm going to add another column on this side for class width, because I don't know why, but I like to keep it next to it. And what is the class width? Well, all you do is you do the big number minus a small number. So that's 20. Big number minus small number, 10. 90 minus 80, 10. 110 minus 90, 20. And now we divide. So frequency is 20 divided by class width is 20, so frequency density is 1. 50 divided by 10 is 5. 60 divided by 10 is 6. 30 divided by 20, so divided by 10 first, which is 3 divided by 2 is 1.5. Again, you can use bus-stop method. So we need to go all the way from 0 at the start, all the way to 6. And if I count how many big squares I have 1, 2, 3, 4, 5. I miscounted. 1, 2, 3, 4, 5, 6. I can go up in ones, and that should be completely fine. So 1 here, 2, 3, 4, 5, 6. And if I count these small squares, I'm going to zoom in now for this part. But there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it makes it really useful for me because I've gone up in ones and there's 10 small squares between them. So each small square is 1 over 10, so 0.1. So that makes it a little more precise. Okay. So we plot the frequency densities in the respective classes. So 50 to 70, so here to here, is 1. So I'm going to go from 50 to 70. 50 should be this one here. And again, I would personally use a ruler, but that would be extremely tedious for me to do right now, so I'm not going to do it. Is that lazy? Yep. 70 to 80 is 5, so 70 to 80, so it's this nice thin piece, is 5, so we're going to go all the way up. For some reason, when I draw lines downwards, I can draw them a lot straighter than if I draw them upwards. So like that. And 80 is the thicker line. And again, don't forget you draw them coming right off each other, okay? There should be no spaces between them. They're all touching. Yeah, it's getting a bit shaky now. Keep it like that. Okay. And 80 to 90 is 6, so this goes even higher. And the 90 line, okay, that's a bit inconvenient. Because I'm surprised they've given you the graph like this, because normally they give it so the lines are a bit nicer, in the sense that they kind of give you solid marks where the classes start and end. But, you know, if they want to make it a bit uglier, that's completely fine. I'll probably cut some of this out just to make it a bit quicker for you guys. And the 90 to 110 is just 1.5, that's nice and quick. So we just got up 1, 2, 3, 4, 5. And it should be up to here. There you go. So that would be your histogram like that. Yeah, there's not much else to say about that. Here are the first 5 terms of a geometric sequence. Work out the next term of the sequence. So what you need to do here is work out what the term-to-term rule is. Okay, and the way you do it for geometric is they're being multiplied by the same thing each time. Okay, so the way I would do this is you just pick 2 of them, so maybe from here to here, right? And you do 20 root 5 divided by 10, which is just 2 root 5. And that gives you what you're timesing by each time to get the next value, okay? So to go from here to the next value, I'm timesing by 2 root 5. So I'm doing 400 root 5 times 2 root 5, times the numbers in front first, so 500 times 2, which is 800. Root 5 times root 5 is 5. So 800 times 5, again, if you times it by 10, which is 8,000, and half it, you get what the value is. Okay? Or you can just do 8 times 5 is 40, add the 2 zeros on. The fourth term of a different sequence. So we actually did this question in one of the live lessons, actually. So this was submitted by someone. Of a different sequence is 5 root 2 over 4. The sixth term is 5 root 2 over 8. Given that all the terms are positive, work out the first term. So what we can do is, again, each time we're timesing by some common ratio, right? So essentially we have the fourth term, then it goes to the fifth term, then it goes to this next term here. So overall, they would have times by whatever the ratio is twice. So we square it, okay? So in other words, if we do 5 root 2 over 8 divided by 5 root 2 over 4, which would be 5 root 2 over 8 times 4 over 5 root 2. So those cancel, this cancel comes 2, that becomes 1, it's a half. And that is the common difference squared. That is the ratio squared, okay? So if I square root that now, we get, of course, 1 over root 2, which is just going to be root 2 over 2. Okay? Or you can say, by the way, leave it as 1 over root 2. Either way is completely fine. But just in case you are checking this on a calculator or something, it would give you root 2 over 2, but they're the same. So again, to go from 4 to 5, we've times by r. To go from 5 to 6, we've times by r again. So overall, we've times by r times r, which is r squared. That's why I've done this. So the first term in the sequence is, we would have to divide it by r to get the third term, divided by r again to get the second term, divided by r again to get the first term. So we're dividing by r 3 times. So we're going to divide by r cubed. Okay? So it's 5 root 2 over 4 divided by 1 over root 2 3 times. So it's cubed. So now we've got this over here. Now we need to do is solve this. When we divide, we keep flip change. So we're going to flip the second fraction. So we get 5 root 2 over 4 multiplied by essentially just root 2 cubed. Now what we have here is we have root 2 times root 2 cubed, which is effectively just going to be root 2 to the power of 4. So root 2 times root 2 times root 2 times root 2. So that's going to be 2 times 2, right? Because we're going to have root 2. If I write it out fully, just so it makes sense the first time we do it, each of these becomes just a 2, right? So we're just left with 2 times 2, which is, of course, 4. Hopefully that makes sense. So we have 5 over 4 times 4, which is equal to 5, which is the correct answer. So that's very nice. And let's go to the next one. So A, B, and C are 3 points, such that AB is 3A plus 14B. Prove that they lie on a straight line. Okay. So I believe I've done this question as well. So we have A, B, and C. Now, if they lie on a straight line, right? So let's say we have these 3 points. So I'm going to assume they're on a straight line because it says show that they are, right? Then hopefully you can see if this. Imagine this is just a normal straight line for a second, right? So we have this length. Then AB is some fraction of AC, right? If it was just a normal straight line, let's say the whole thing was 10 centimeters long, then you would say that AB is some fraction of 10 centimeters, and you'd be 100% correct in saying that. Same thing with vectors, okay? So if I can write this vector in terms of this vector, then they must lie on a straight line, because all they are is a stretch of one another. So if you notice, I can write AC, if I factorize out a 5, I get 3A plus 4B, which is the exact same as this vector here. So in other words, it's just 5AB, which means they must be the same. So they're on the same line. Okay, and because it's positive, it also means they're in the same direction, but for the marks, you only need to write that they're on the same line, okay? Then it says D and F are 3 points on a straight line such that this, okay, cool, so what I would do is I would draw out D, E, F, like so. And D to E, right, this vector here is 3E plus 6F. Again, I underline my vectors just so you can see them. So I can't write in bold, hence why I underline any letter that has bold overlays. And E to F is, yep, that's fine, minus 10.5e minus 21f, right? It says find the ratio of the length of d to f and de. Well, if I look here, again, imagine it's just the length of a line normally, right? Let's say this here was 5 centimeters, this one was 10 centimeters. To find the total length, you'd add them, right? Same with vectors. So df is just going to be the sum of these two vectors that we have here, 3e plus 6f minus 10.5e minus 21f. So 3e plus minus 10.5e is minus 7.5e. And then 6f plus minus 21f would be minus 15f. And then we have the length de already. So what we would do is, if I write the length de down here, right, all I do is I work out how many times bigger df is than de. So the way I would do that is I would say, what's 7.5 divided by 3? Well, that's actually 2.5. And the fun thing is about that is, so to go from here to here, all I'm doing is dividing by 2.5. Minus 2.5, I should say, actually. So I should actually count the negative sign. So in other words, the ratio of df to de is 5 over 2 to 1. Right? So actually, if I want to write this a bit more properly, just to keep it in the same vein, because df is 2.5 times bigger, it's 2.5 to 1. Now, generally speaking in ratios, we always give them as whole numbers. So I'm going to times both sides by 2, just to make it a whole number, which gives me 5 to 2, which is the final answer. Okay, so this one, I think I've done this one as well, actually. We have proved that 2n plus 1 squared minus 2n minus 1 squared is equal to this. And if you notice, this is actually a difference of 2 squares, because both of these things are squared. So if you remember, like if you have like x squared minus 100, right, you just do x plus 10, x minus 10. And the reason is both of these numbers are square numbers, okay? It's actually the same thing no matter what you have. So in general, if you have a squared minus b squared, you just have a plus b, a minus b. So in this case, a is just equal to all of this, and b is just equal to all of this. So let's work that out. So we have 2m plus 1, so that's my a, right? Plus, so 2m plus 1 is my a, 2n minus 1 is my b, so plus 2n minus 1, oops, times, almost made a mistake there, 2m plus 1, and now this is where things are going to get a bit tricky because it's subtract b. So when I'm subtracting b, I need to flip the sign of everything inside this bracket. So instead of 2n, it's minus 2n, and instead of minus 1, it is plus 1, okay? So now we can actually simplify these brackets. So we have these two ones are going to cancel. So we're going to have 2m plus 2n times 2m minus 2n plus 2. Now if you notice from both of these brackets I can factorize out a 2, and if you look here, like if I want to make this first bracket look like this bracket, they've factorized out a 2, and likewise here these brackets look very similar, they've just factorized out a 2. Now because I'm taking a 2 out of both brackets, in total I'm taking, I mean if I write it like this, maybe this will make more sense. Actually no, it won't, because I've just made a mistake there. 2m plus n, 2m minus n plus 1. Now, because we have 2 in front of both of these brackets, you actually bring them to the front and they times together. Okay, because don't forget, all of this stuff is actually multiplying, and the order of multiplication does not matter. So that's how they get that. Sophia then says that the result in A shows that the difference of the squares of any two odd numbers must be a multiple of 4. Is she correct? Well, let's have a look. Is this first thing an odd number? Well, think about it. It's 2 times an integer, which will always be even, plus 1, which will always be odd. So this, for sure, is odd. What about 2n minus 1? Is that an odd number? Well, 2 times any number is even. -1 is always odd. So this does indeed prove that an odd number squared minus an odd number squared is always a multiple of 4. So the multiple of 4 bit comes from the fact that they factorized out a 4. So you would say yes. And the reason for that is 2m, was it 2m plus 1, 2n minus 1? Yeah. 2m plus 1, and I should write and, 2n minus 1 are both odd. And the right hand side is a multiple of 4 because they factorized out a 4. Oh boy. Alright, we've had a very similar question to this recently. It was the one before, I can't remember what number it was, 9 or something. So again, the technique is to combine these fractions, multiply up, and then continue. So to do that, I'm going to times this first fraction by everything in the denominator on the right hand thing here. Okay, so 1 times x minus 1 gives me x minus 1. That's over 2x minus 1, x minus 1, plus 3, and we're timesing it by this denominator now. So that's 2x minus 1 over, and I'm going to write it in the same order just so it's super duper clear, equals 1. Combine the fractions. We have x minus 1 plus 3 2x minus 1 over 2x minus 1 x minus 1. Now, I always say that I like to get rid of any brackets. I'm not going to get rid of the bottom brackets. I know that's kind of ironic considering I just said to get rid of them. But if they're on the denominator, I'm going to leave them for now. So I'm going to get rid of the brackets in the top, which gives me x minus 1 plus 6x minus 3 all over 2x minus 1 x minus 1 equals 1. Simplify that. X plus 6x is 7x minus 4. And what I can do is I can actually multiply up these brackets as well to the other side. So that will equal 2x minus 1 x minus 1. Expand the brackets, and then as you can see, it's just going to be a quadratic that we're going to solve using the quadratic formula. So 7x minus 4 equals, that would be 2x squared, minus x minus 2x, that would be minus 3x, minus 1 times minus 1 is positive 1. I'm going to move this stuff on the left hand side to the right hand side, so move that all over. That gives me 2x squared minus 3x minus 7x, that's minus 10x. And again, we're minusing because I have to move it to the other side. Then it'd be plus 1, and that minus 4 now becomes plus 4, so it's plus 4, so that'd be plus 5 equals 0. Now we use the good old-fashioned quadratic formula. So I've written it a few times already, so minus b plus minus the square root of b squared minus 4ac over, 2a. So b in this case is minus 10, a is 2, c is 5. So again, please make sure you use the brackets to avoid making mistakes. And this 4, because again, don't forget this first thing, it isn't just minus 10, it's minus minus 10, okay? Believe me, a lot of people make that mistake. And that's 5 over 2 times 2. So if we try and simplify this now, minus minus 10 will give me 10 plus minus the square root of 100. So that's minus 4 times 2 is minus 8 times 5 is minus 40 over 4. And I just want to check what the form the thing gives. So it needs to be over 2, so that's quite nice. What we can do there is equals 10 plus minus the square root of 60 over 4. So what I want to be able to do is divide the top by 2. So, well, I've run out of space mostly because my writing's a lot bigger because I've gone on the screen. So what I want to do then is I want to pull out a 4 from this. Because if I pull out a 4, that will give me a 2 on the outside here, which I hope that makes a bit of sense. Okay. So again, I could have pulled out something bigger. Actually, maybe not. So that equals 10 plus or minus 2 root 15. And now I can divide the top and bottom by 2 because we can. So that'd be 5 plus minus square root 15 over 2. So if I look at the answer, P is 5, Q is 15, 2 is 2. Okay? Perfect. Okay, this one is going to be funky to do, and the reason why it's going to be funky is because I have to use the ruler setting on my calculator, what am I talking about? My thing, and this thing does not work very well. So we need to describe fully the single transformation that maps P onto Q. So first of all, I can see it's an enlargement, right? So I'm going to write enlargement. You need all 3 of these ingredients to get full marks. So normally you get 1 mark per thing you say, but unfortunately in this question we only have 2 marks. So you have to have all 3 pieces. Any one piece that's missing, you drop a mark, okay? So you need to say what transformation is, enlargement, so we've got that. You need to say what the scale factor is, and then you have to say what the center of enlargement is, okay? So normally you get 3 marks for this, but sometimes you get 2. If you don't have any of these, one of these things, you drop a mark. So if I don't say enlargement, drop a mark. Don't say scale factor, drop a mark. Don't say center, drop a mark, okay? So how do I figure out the scale factor and the center? Well, the scale factor, I like to look at any flat edge. So can you see here, this is flat and this is flat, okay? So it's going from, so for P onto Q, so it's getting smaller, so it should be a fraction. So if I look at the top side, for example, 1, 2, 3, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's being divided by 3, right? And now to check, this is 3 and it goes to 1, so it's being divided by 3, which is the same as a scale factor of 1 over 3. Because remember, scale factor is always timesing, okay? So, let's go through it. By the way, just whilst we're on the topic, as I've gone through this, and this is the same for some of the other grade 9 papers, it's really frustrating. I've emailed Edexcel about this, but some of the answers are wrong. And that is a bit of a shame. So you can try and use this as your mark scheme, and I know that sounds extremely arrogant for me to say, don't trust them, but I'm hoping. So for example, the answer to this question is wrong on the mark scheme. So if you spot any other questions, like if you think I'm wrong, call me out in the comments, that's fine. I'll double check it. I'll check your logic as well. If I'm wrong, then I'll put a little comment. I've done it before. However, if the mark scheme is different, use your own logic and use my logic, see which one makes sense, but do let me know. Anyways, to find the center of enlargement, what you have to do is look at the corresponding lengths, okay? So this corner here is this corner here on this point. So what I'm going to do is draw a straight line through them. I'm going to hope that my ruler actually does line up pretty well. Again, bear in mind my ruler isn't as flexible as yours. And you just draw a straight line going through them. Oh no, that was so tragic. Alright. Alright. Again, yeah, mine's going to be slightly off because, again, I can't angle it fully. Actually, that looks pretty good. Alright. And you do this for every single one of the corners. I know, it seems boring. It is boring, believe me. And I have to do it with this terrible ruler. So I do understand and feel your pain. No, that was the wrong way. So can you see it's like between 2 angles for me? Okay, that's close enough. Again, for you, it's not close enough. Okay. And you probably already see roughly where it is. So again, it's going to be 0, 2. For you, if you do this on pen and paper properly, where your ruler can go fractions of a degree, you'll find that it crosses at 0, 2. Now, technically you're supposed to do this with all 4 corners, but you can probably already see where it's lining up, right? You can see where it's going to be on 0, 2. Let's keep going just for the sake of completion. See how much it's jumping every time I do it. So yeah, it's between these 2 again. So, like I said, do this on... Oh, what's happened again? Do this on pen and paper, and you'll get a far more accurate answer. You'll get a bit more of an accurate answer. But I can see it's going to be 0, 2. So that's what I'm going to draw next. 2 root 2. So do you remember when I did the root 2 over 2? Would give me... Okay, and with the last one, let's just coast it in. Again, you could do this a lot faster in real life and also a little better than me. And that's okay, it's reasonable enough, I suppose. Cool. But the point is here that, for mine at least, it's going to cross at 0, 2. So that's what the centre of enlargement is. Perfect. Okay. So we have a solid sphere and a solid cone. I've seen a similar style of question, at least I think I have. The volume and the volumes are the same. Cool. So what they're trying to tell you here is that the volumes are the same. So all we have to do is equate these two things together. Not too bad. 4 over 3 pi r cubed. Whoops. Equal to a third pi r squared h. Cancel out the pi's from both sides. Cancel out the over 3's. Cancel out r squared. And you're left with 4r equals h. So in other words, r to h is just 4 to 1. Nice and easy. Different sphere and different cone. Cool. We have the surface area and the total surface area is the same. Okay. So what they're saying here is the surface area of the sphere is 4 pi r squared is the same as pi r l. But wait, that is the area of the curved surface. So the bottom is going to be the area of a circle, which is pi r squared. Okay. Now, okay, so r to h. H in this case, it must be the height of the cone. So, I mean, in the previous diagram, h is the height of the cone, so we can say it's the same thing. If you notice, this is a right-angled triangle. So I don't want L, so all I'm going to use is Pythagoras to say h squared plus r squared is equal to L squared, which means L is just equal to the square root of h plus r. H squared plus r squared. Almost made a fatal error there. But the first thing I want to do is, again, because pi is in every term, we can just get rid of it, which is pretty nifty. I can also minus r squared from both sides. That leaves me with 3r squared equals r times L, which is h squared plus r squared. Now, in the answer, we want r to h, so we want to move all of the r's to one side. I can actually cancel out an r from both sides as well. That's handy. So we're left with 3r equals the square root of h squared plus r squared. Plus r squared. And it does say square root integer. Okay, cool. So if I square both sides, that would give me 9r squared equals h squared plus r squared. Move the r squared to the other side. We have 8r squared equals h squared. Let's square root both sides now. So that would give me the square root of 8r is equal to h. So in other words, h is root 8 times bigger than r. Okay? So then if we're doing r to h is root 8 times bigger. So we're just going to have 1 to root 8 for that question. Cool. First aid test has 2 parts, a theory and a practical test. The probability of passing a theory is 0.75. Probability of passing only one is 0.36. They're independent. Remember, independent events, their probabilities don't affect each other, right? So an example is, if I flip a coin and roll a dice, what I get on the coin does not affect what I get on the dice roll. Whereas if, for example, like the probability of me taking an umbrella to work, that is affected by the probability it rains, right? Because if it rains, the probability that I take an umbrella is a lot higher than if it's a dry, sunny day. Or even like the time of year, for instance. So those aren't independent because they change. So I would personally do a little tree diagram. So if the theory, then we have the practical. I don't believe we know anything about the practical, do we? No, not really. So we have, let's say, pass and fail. Passing is 0.75, which means the probability of failing must be 0.25 because they must add up to 1. And then we have, again, pass, fail, fail, and we don't know what it is, right? And there's no other information. Cool, I think we're right. Now it says the probability of passing only 1 is 0.36. So how would I work that out? Well, there are two ways to only pass 1. Either I've passed the theory and then failed the practical, or I've failed the theory and passed the practical. Now, what am I going to label my probabilities for passing and failing? Well, let's label the probability of passing as P, right? Now, because I don't want more unknowns, right, the probability of failing will be 1 minus P, because again, there's only two possibilities, right? And that means I only have one unknown in any equation I have. So the two possibilities are 0.75 times 1 minus P, plus, because remember, if you have two different ways of doing something, you add them together because it's an OR. So OR 0.25, and it's passing, so I hope that makes sense, which is P. That should equal 0.36. Now it's just a normal linear equation. Six. Gather the like terms and move 0.75 to the other side. So that would be negative 0.5p equals 0.36 minus 0.75 is 39 minus 0.39. Yep. And no. Yeah. Because to go from there to there. Cool. And then all you need to do is, well, because they're both negative, we can cancel out the whole negative shtick. And then all we need to do is multiply both sides by 2 to get rid of the 0.5. Or you can say divide by by half if you want. Either way is fine. So that's 0.78. Nice and easy. For marker, it's not too bad, I think, personally. Okay, is this the last question? No, God, no. A right angle triangle is formed by the diameters of 3 semicircular regions, A, B, and C, as shown in the diagram. Show that the area of A is equal to B plus C. So it almost looks like Pythagoras, which, funny that, isn't it? So if I label these sides, C squared, B squared, right? What would the areas be? So I want to say area C. Well, all you do is you do a half, because it's a semicircle, pi times radius squared. Now, the radius is C. So it'd be C over 2, well, technically C over 2 squared. So I've actually labelled this incorrectly. Sorry about that. I just realised as I did it, I should label it A, B, and C, not A squared and B squared. It's because I was thinking of Pythagoras, right? That would be the area of this one, right? So that would equal a half, so that would be a quarter. So wait, let me just do this out. 1/2 pi times C over 4. So in other words, it'd be 1 over 8 pi C. So the same thing for A and B. We're going to have the same thing, isn't it? Yeah, literally the same thing. So do the same thing for A over 1/2 pi. And hopefully you can see it's literally going to be the exact same thing. An 1/8 pi A. And for B, you can probably guess it's going to be an 1/8 pi B. Okay. Now, these are all our areas. So let's now write it as if it is this, right? So it's saying A, an 1/8 pi A equals an 1/8 pi B. Shouldn't that be squared? It should be squared. I'm being silly. Squared, squared, plus an 1/8 pi C squared. Have I made any other mistakes? No. Okay, now if you notice, I can actually cancel out the 1/8 from every single term. I can also cancel out the pi from every single term. That just gives me A squared equals B squared plus C squared. This is actually a proof for the Pythagorean theorem, which is fancy. So therefore, the area of A is just equal to the area of B plus the area of C. Yeah, just a proof of Pythagoras. Have fun. Now this is the last question. Okay, this question I actually did. Let's go through it again. The reason why I get so excited about this is because these questions are always, every single year, or at least every year that they do this, it always comes out on Reddit and Instagram. They say the impossible maths question every single year, and they'll have overlapping circles. There was one, or not even overlapping all the time. They might just have a circle, as in 3 circles, but there's always 3 circles. And what they do is they say, work out the total circumference around them, or whatever, the total perimeter or whatever. The method is always the same. What you're going to do is create a bunch of equilateral triangles. So let's do that. And what I mean by that is, if I draw a line from A to this point here, that's the radius, right? Line from here to here, that's the radius, right? Line from here to here, that's the radius, right? Again, radius, radius, and radius. And if you notice, so the first thing I want to say when I do this is this bottom section is the exact same as this top section. So what I'm going to do is work out the top section and double it, okay? Because again, the bottom and the top are the same. That's why I'm not doing the same thing on the bottom side as well. But you could do this same thing upside down if you want. All of these are equilateral triangles, okay? Cool. So they're all equilateral. Perhaps I should write that. All equilateral triangles. Triangles. Now what's more is, if I look at this shape now, if I want to work out the grey area, I can work out the the area of this sector. Can you see it's a big sector? It looks like a pizza slice. There's a big old sector right here. And then subtract these 2 segments. Yeah? So let's do that. We're going to do the area of a sector. And then what we're going to do is subtract 2 times the area of these segments. Okay? Now, how do I work out the area of a sector? Well, I take the angle, I divide it by 360 and do pi r squared. Now, if I look at this angle here is 60 degrees. Why? Because all of these angles are 60 degrees, and angles on a straight line add up to 180. So this is 60 degrees, this is 60 degrees, this is 60 degrees. So I'm going to do 60 over 360 times pi times the radius, which is 4 squared. Now 60 over 6, cancel that. 6 over 36 is a sixth, so it's a sixth times 4 squared is 16 pi. So we can probably simplify that a little bit. Half both of the numbers, so it's now 8 over 3 pi. And that's it. Okay. So far, so good. Now we need to work out the area of these little segments here. Okay? So if I rub this out now, actually, will that make sense? Yeah. So now I'm going to work out the area of these little segments. And again, both of these are the same. Okay? So I'm only going to work out the area of one and then double it. So the area of segment. Now the question is, how to work out the area of a segment? Well, it's the area of the sector minus the area of the triangle. Okay? So the area of the sector is going to be actually the same as this, 8 over 3 pi, but I'll show you why. And the area of a triangle is a half AB sine C, where A and B are 2 lengths and C is the angle between them. And if you notice, this angle here is also 60 degrees, and of course the lengths are both 4. So, area of a sector, again, angle is still 60 degrees, so it's 60 over 360 times pi, and the radius is 4, so times pi times 4 squared, which again is just going to equal 8 over 3 pi, right? So that's for that part. Should I have done that? Okay, put that on the next line down. Area of a triangle is going to be a half 4 sine 60, okay? And that's good so far. So again, we've already done the first step in the next lines, 8 over 3 pi. Now, if you remember, 4 times 4 is 16, divided by 2 is 8 again. Sine 60 is one of those sine values you need to remember. It's root 3 over 2. I have a technique for how to memorize that in my Everything You Need to Know for AQA/EdXL videos. There's 2 separate videos. But I reckon what we want to do here is... Do we want to leave it? Let's leave it for now. So, the area of this top bit here, yeah, the shaded area, equal to 2 times. So remember, we've only worked out the top section now. Well, we're working out the top section. So to get the bottom, I'm going to double it. So it's 2 times the area of a sector minus the area of a segment. Okay? Minus. Now if I minus this, I get minus 8 over 3 pi. But then remember, the sign flips for this side and it becomes plus 8 root 3 over 2. Okay? Hopefully that makes some amount of sense in that case. So, worked out the top part, we've done... hang on, sorry. We need to multiply this by 2, don't forget. So that might be confusing now. Because remember, the top half is the area of the sector minus 2 lots of the segment. Okay? And then we're doubling that afterwards. So now we can expand. We have 2 times 8 over 3 pi minus 16 over 3 pi plus, yeah, now it's plus. Should be plus back here. 16 root 3 2. Now we can simplify what's inside the bracket. 8 over 3 pi minus 16 over 3 pi would be... It would be 8 over 3 pi minus 8 over 3 pi. Yeah, of course it would be. What am I talking about? I don't know why I found that difficult. And then plus 16 root 3 over 2. And then if we times it all by 2 now, because it's inside the bracket, we have minus 16 over 3 pi plus 16 root 3. Which is your final answer. So again, with this part here, this 2-bit, it's a bit messy, so let me go through it one more time. So the area of this top shaded area is going to be the area of the sector, which is 8 over 3 pi, minus 2 segments, because we have 1 here, we have 1 here. So 2 times the area of the segment, which is 8 over 3 pi I didn't even read it. Minus 8 root 3 over 2. Yeah. So open that out. 8 over 3 pi minus 16 over 3 pi plus 8 root 3. Simplify that. You get 8 over 3 pi plus 8 root 3. And then to get the bottom section as well, we times this whole thing by 2, which again gives us 16 over 3 pi plus 16 root 3. So hopefully that makes a bit more sense than my previous answer. But that brings us to the end of the 2023 paper 1. Let me know if you want paper 2 and 3. Maybe I'll upload them after paper 1's done, because we only have, I think it's like 26 days until paper 1. But yeah, let me know what you think.